In this video, we will try to solve these challenging problems related to equation of a circle in standard form. You may check the previous video to recall the basic concepts of circle and its equation. Now, without further ado, let's try to solve the first given. In here, we have to find the center of this circle given this equation, and the radius from another equation of a circle. To easily find them, we have to rewrite these equations first into a standard form. Do you still remember the method, completing the square? This method will let us rewrite a general form of equation of a circle to a standard form. As for this given, to write this general form to standard equation, we have to arrange it so that terms with variables x and y are grouped together on the left side of the equation, while the constant is on the right. Next, we have to form two perfect square trinomials by completing the square. Starting with the term 6x, we divide its coefficient by 2, which is 3, then square it, to get 9. This will then be added on both sides of equation. We now have our first perfect square trinomial on the left, as x squared, plus 6x, plus 9. Again, don't forget to add 9 on the right side of the equation as well. We do the same for the coefficient of y. We divide it by 2, which is 11, then square it, to get 121. We add 121 in both sides of the equation so that we will have another perfect square trinomial as y squared, plus 22y, plus 121. Remember, perfect square trinomial can be written as square of binomial. So in this case, x squared, plus 6x, plus 9, can be written as x plus 3, squared. While y squared, plus 22y, plus 121, can be written as y plus 11, squared. Perform the operations on the right side of the equation, negative 120, plus 9, plus 121, equals 10. Hence, the standard form of this given equation is x plus 3, squared, plus y plus 11, squared, equals 10. Since the circle we are looking for has the same center as this one, we just need to determine the coordinates of the center in this standard form of equation, which is negative 3, negative 11. Next, we'll find the radius in this given equation. But, we have to rewrite this again to standard form, following the steps that we did a while ago. Group the terms in the equation, with constant on the right side. For the coefficient of x, divide it by 2, then square it. We get 25. Add 25 on both sides of the equation. Do the same for the coefficient of y. Divide it by 2, then square it. We get 9. Add 9 on both sides of the equation. Then we'll have two perfect square trinomials. Write them as squares of binomial, and simplify the right side of the equation. Therefore, the equation in standard form is x plus 5, squared, plus y plus 3, squared, equals 16. Note that the circle we want to find has a radius similar to this equation. From this standard form of equation, we know that r squared equals 16. Hence, the radius is 4. Now, writing the equation of a circle whose center is at negative 3, negative 11, and radius 4. We have x plus 3, squared, plus y plus 11, squared, equals 16. This circle has its center on the line y equals 2x minus 13, and tangent to the line y equals negative 3x plus 57, at 16, 9. In order to solve this, Let us try to recall some of the concepts related to this problem. A line is tangent to a circle if it touches the circle at exactly one point. That one point where the circle and the line intersected is called the point of tangency. A theorem that is worth recalling in order to solve this problem is that the tangent line is always perpendicular to the radius of a circle, drawn from the center, to the point of tangency. Going back to our given, the center of our circle is anywhere on the red line, represented by y equals 2x minus 13. And the circle must touch the blue line represented by y equals negative 3x plus 57, at 16,9. Again, tangent line is always perpendicular to the radius of the circle drawn from its point of tangency. So, we draw a line perpendicular to the tangent line. Then we can determine the center of the circle from their intersection. But first, let us find the equation of this perpendicular line. We know that this line passes through 16,9. If we can find its slope, then we may be able to use point-slope form to determine its equation. Fortunately, there is another theorem that can help us in this. That is, the slopes of two perpendicular lines are negative reciprocals of each other. Since the tangent line has already an equation in slope-intercept form, we can just easily identify its slope. That is, negative 3. And with the theorem that says, perpendicular lines are negative reciprocals of each other, we can say that the slope of the perpendicular line would be 1/3. Then we'll have the given point, 16,9, using point-slope form, y minus y sub 1 equals m times x minus x sub 1, we will have y minus 9 equals 1/3 times x minus 16. Or, in slope-intercept form, y equals x over 3 plus 11/3. Therefore, the equation of this perpendicular line is y equals x over 3 plus 11/3. If we want to remove fractions, we can just multiply the equation by 3, so that it becomes 3y equals x plus 11. Solving for system of linear equations between these two equations will allow us to determine their points of intersection, which is also our center. By substitution, we can let y equals 2x minus 13 and substitute it to y of our second equation. So we have 3 times 2x minus 13 equals x plus 11. Simplifying this, then solving for x, we will have 6x minus 39 equals x plus 11. Then combining like terms, we have 6x minus x equals 11 plus 39. Then, we'll get 5x equals 50. Divide both sides by 5, we get x equals 10. This is now the x-coordinate of our center. Now, we only have to find y. Using the value, x equals 10. We can substitute this to any of our equations. For this, we can use the first, which is y equals 2x minus 13. Substituting x equals 10, we have y equals 20 minus 13, or y equals 7. Our y-coordinate is 7. Therefore, the point of intersection of the two lines is 10, 7. This will be the center of our circle. Now, with center at 10, 7, our only task left is to find the radius of the circle. To do that, we can use distance formula from the center to the given point of tangency. Let us denote the coordinates of the center as x sub 1 and y sub 1. While the coordinates of the point of tangency is x sub 2 y sub 2. Applying the formula, we will have the square root of 16 minus 10 squared plus 9 minus 7 squared. Simplifying this, we have 6 squared plus 2 squared, or square root of 36 plus 4, equals square root of 40. Hence, our radius is square root of 40, or 2, square root of 10. Now that we have the center, and the radius, we can now generate our standard form of equation of this circle. With h and k, as 10 and 7 respectively, we can have x minus 10 squared plus y minus 7 squared equals 2 square root of 10 squared. Simplifying this, we have x minus 10 squared plus y minus 7 squared equals 40. For the last problem, we are asked to find the standard form of equation of a circle passing through 3 points, 11, 5, 6, 10, and 3, 1. And we will be using the general form of equation of the circle. The idea here is to substitute each point's x and y coordinates to this equation, and find the values of variables d, e, and f, using system of 3 equations in 3 variables. So for the first coordinate, 11, 5, we can substitute this general form of equation with x equals 11, and y equals 5. We will have 11 squared, plus 5 squared, plus d times 11, plus e times 5, plus f, equals 0. Simplifying this, we can get 121, plus 25, plus 11d, plus 5e, plus f, equals 0. Transpose 121 and 25 to the right, we will get 11d, plus 5e, plus f, equals negative 146. This will be our first equation. For the second coordinate, we will do the same. We will substitute x equals 6, and y equals 10, to the general form. We will get 6 squared, plus 10 squared, plus d times 6, plus e times 10, plus f, equals 0. Simplifying, we have 36, plus 100, plus 6d, plus 10e, plus f, equals 0. Transpose 36 and 100 to the right. We can get our second equation as 6d, plus 10e, plus f, equals negative 136. As for the last coordinate, we will substitute x equals 3, and y equals 1, to the general form. We will get 3 squared, plus 1 squared, plus d times 3, plus e times 1, plus f, equals 0. Simplifying, we have 9, plus 1, plus 3d, plus e, plus f, equals 0. Transpose 9 and 1 to the right. We can get our third equation as 3d, plus e, plus f, equals negative 10. After generating these equations from the coordinates, we can now solve for d, e, and f, using system of 3 equations. Start by choosing a pair of equations to eliminate one variable. Say for example, we have equation 1 and 2. Looking at the two equations, we can easily eliminate variable f, if we can subtract the two equations. Applying this, we have 11d minus 6d is 5d, 5e minus 10e is negative 5e, f minus f is 0, and negative 146 minus negative 136 equals negative 10. Hence, we have 5d minus 5e equals negative 10. Let us denote this as equation number 4. Next, choose another pair of equations where we can eliminate variable f. In this case, I have chosen equations 2 and 3. Subtracting the two equations to eliminate f, we have 6d minus 3d is 3d, 10e minus e is 9e, f minus f is 0. And negative 136 minus negative 10 equals negative 126. This will then be our equation number 5. Notice that equations 4 and 5 are linear equations in two variables. Therefore, we can use system of linear equations in two variables to again eliminate a variable and solve the other one. We can use elimination for equations 4 and 5, however, we don't have variables with similar coefficients that we can add or subtract in order to eliminate. So what we can do to, let's say, eliminate variable d, is to multiply the equation number 4 by 3, so that the coefficient of d becomes 15. And multiply equation number 5 by 5, so that the coefficient of variable d is also 15. So 3 times 5d is 15d. 3 times negative 5e is negative 15e, and 3 times negative 10 is negative 30. Next, 5 times 3d is 15d. 5 times 9e is 45e, and 5 times negative 126 is equal to negative 630. Now we can use elimination. We have 0. Negative 15e minus 45e is negative 60e. And negative 30 minus negative 630 is 600. Dividing negative 60 to both sides of the equation, we can get the value of e as e equals negative 10. Now that we have the value for e, we can use it to find the value of d, using equation 4 or 5. In this case, I chose equation 4. So substituting e equals negative 10 to the equation, we have 5d minus 5 times negative 10 equals negative 10. Simplifying, we have 5d plus 50 equals negative 10. Transpose 50, we have 5d equals negative 10 minus 50. Or 5d equals negative 60. Dividing 5 to both sides of the equation, we will get the value of d as d equals negative 12. We are now down to our last variable, which is f. To find its value, we can simply substitute the values of d and e to any of the equations 1, 2, and 3. In this case, I chose equation number 3. So using 3d plus e plus f equals negative 10, with d equals negative 12 and e equals negative 10, we have 3 times negative 12 plus negative 10 plus f equals negative 10. Simplifying this, we have negative 36 minus 10 plus f equals negative 10. Transpose negative 36 and negative 10, we have f equals negative 10 plus 46. Finally, we have the value for f as f equals 36. Now that we have the values for d, e, and f, we can form this circle's general form as x squared plus y squared minus 12x minus 10y plus 36 equals 0. But we're not yet done. The problem asks us to find the equation in standard form. So writing this equation to standard form, we will use completing the square. Arrange our equations so that terms with x variables, and terms with y variables, are grouped on the left side of the equation, while the constant is on the right. Divide the coefficient of x by 2, and square it, to get 36. Add 36 on both sides of the equation. Do the same for the coefficient of y. Divide it by 2, and square it, to get 25. Add 25 on both sides of the equation. Now that we have our perfect square trinomials, we can rewrite them as squares of binomial. X squared minus 12x plus 36 can be written as x minus 6 squared, while y squared minus 10y plus 25 can be written as y minus 5 squared. As for the right side of the equation, negative 36 plus 36 plus 25 equals 25. Therefore, the circle being asked in this problem, that passes through points 11, 5, 6, 10, and 3, 1, has equation x minus 6 squared plus y minus 5 squared equals 25. Thank you again for watching. Hope you learned something from this video. If you do, kindly give us a like, subscribe, and hit the notification bell to get more lessons in mathematics for senior high.